Welcome to 6WIN's vRouter webinar, where we will present our VPN Concentrator vRouter. My name is Kelly LeBlanc. I run 6WIN's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIN's VP of Product Management, based at our headquarters in France. Jan will introduce our VPN Concentrator vRouter solution in detail with a demo. We will conclude with a Q&A. Please use the Q&A button at the bottom of your screen to submit your questions, and we will answer them in the order that they are received. First, let me start with a quick introduction of 6WIN. 6WIN is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. 6WIN has two product families. The first is 6WIN Gate, a complete Layer 2 through Layer 4 networking stack available in source code and optimized for commercial off-the-shelf servers, including x86 and ARM. 6WIN Gate is integrated by OEM vendors to develop a complete networking appliance, solution, or system for use cases such as 5G, TCP, telecom infrastructure, and more. The second is our vRouter product family with options for applications and infrastructure. 6WIN Turbo Router, Turbo IPsec, and Turbo CGNAT are vRouters in the form of software appliances that lead the market with a performance advantage. Today we will focus on Turbo IPsec for the VPN Concentrator use case. 6WIN Virtual Accelerator is a vRouter that fulfills all the requirements to power hypervisors with the necessary features for virtual networking infrastructure, used in network function virtualization or NFV infrastructure, and other virtualization use cases. Popular use cases for our vRouters include border routers, IPsec VPN gateways and concentrators, carrier-grade NAT, and more. Here is a list of some of our key customers, many of which are brand names in the networking and applications market. Many networking companies such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our software for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, Bloomberg, and OVH use our vRouters to build their networks and services. In today's webinar, we will start with an overview of our VPN Concentrator vRouter based on our Turbo IPsec software appliances, followed by a VPN Concentrator software demo. At the end, we have time for Q&A. Let's begin with a product introduction of 6WIN Turbo IPsec. 6WIN Turbo IPsec is a vRouter that is beating legacy security equipment in global markets thanks to our innovation. The competition is intense right now as we are competing against large incumbent networking companies and focused security hardware vendors. We've been influencing these customers to think differently with our price performance value proposition and new way of solving mainstream security problems. This new way of thinking is thanks to our high performance vRouter software for commercial off-the-shelf servers. Here you can see a VPN Concentrator use case deployed through Turbo IPsec, which Jan will detail in his demo. AT&T is the largest Tier 1 service provider in the US and uses 6WIN's vRouter as a VPN concentrator for its enterprise VPN service called vVig, or Virtual VPN Internet Gateway. Our Turbo IPsec vRouter is used to aggregate the IPsec traffic from enterprise users. As a result of using our Turbo IPsec on a commercial off-the-shelf server, AT&T was able to reduce direct CapEx by 70% and support IPsec clients of all types and thousands of IPsec tunnels. Now let's look at 6WIN Turbo IPsec's features. 6WIN Turbo IPsec can be deployed in bare metal and virtual machine configurations. Its features include IPv4, IPv6 networking with support for VRFs, BGP, OSPF dynamic routing, tunneling, NAT, PPPoE and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, lag, high availability and redundancy, and more, all in software. IPsec VPN functionality is available through IPsec and IKE features for secure VPN tunnels and connections between sites, data centers, or mobile infrastructure. 6WIN's IPsec VPN performance is impressive, and this is one of the reasons we've won so many use case awards. On an Intel Xeon E5 processor, we benchmarked 12 gigabits per second of throughput per core, up to 100,000 IPsec tunnels and 1,000 tunnels per second, all in software. And performance scales linearly with the number of cores. Combining VRF, IP, and filtering to create IPsec VPN tunnels, we deliver 7 gigabits per second per core. And for customers who are now leveraging Intel's new Xeon Scalable processor family, you can see we increased performance by 50% on the new Intel Xeon Platinum processors. Here we can deliver 18 gigabits per second per core and 10.5 gigabits per second per secure VPN tunnel. It is the same 6WIN software that gives you a 50% performance increase on the latest generation processors. 6WIN's vRouter allows you to build a range of solutions on commercial off-the-shelf servers with the same software. We support a range of powerful Intel CPUs, from the Atom processor all the way up to the latest Xeon Scalable processors and 1 to 100 gig NICs. Many of you already have servers from one of these leading vendors, so you're ready to go. Just download our software and you can have a VPN Concentrator vRouter with 1 to 100 gigs of throughput performance according to your requirements. If you are purchasing servers for your deployment, you have a wide range of options and flexibility for bare metal and virtual machine deployments. We license our Turbo IPsec software with 1 gig to 100 gig options, plus the number of secure VPN tunnels that you need. Now for deployment options. Here we see 6WIN's vRouter deployed bare metal on commercial off-the-shelf servers or within virtual machines. Within VMs, there are 3 options with varying levels of performance. The first is on top of standard open source hypervisor infrastructure using Open vSwitch or Linux Bridge, with hypervisor options including Linux KVM, VMware ESXi, and Amazon Web Services. The second leverages hypervisor bypass technologies such as SRIOV or PCI pass-through, which dedicate hardware resources to virtual machines for the highest performance, but loses some of the benefits of virtualization, such as live migration. The third runs on top of 6WIN's Virtual Accelerator vRouter in the Linux KVM hypervisor domain for the best virtualization performance with 0 hardware dependence. Performance is close to bare metal, and virtualization features are preserved. We give you these different deployment options so that you can make incremental software upgrades for your cloud transition. Remember, it's the same 6WIN software for bare metal or virtual deployments. 6WIN vRouter provides both traditional CLI-based management and IT-style management based on automation and integration with high-level orchestration tools. For this, 6WIN vRouter-based NetConf API. Configuration can happen through the CLI and NetConf API for integration with third-party management tools and orchestrators. Our data models leverage Yang and are therefore easily understandable and extensible. For deployment, we provide packaged images for bare metal, KVM, VMware, and AWS, and leverage the Linux Cloud Init features that enable the customization of day 1 configuration at startup, including initial networking configuration, default users, custom software packages, and configuration files. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus telemetry through SFlow and graphical analytics with time series database. We have pre-integrated the vRouter with InfluxDB and Grafana, which are standard open source time series database and analytics software. Our integration and default Grafana dashboards are available on GitHub for the community to download and extend. Now let's walk through some examples of real-world cost savings when comparing 6WIN's Turbo IPsec vRouters on commercial off-the-shelf servers versus hardware IPsec gateways. Let's do the math. We need to prove that cost savings with vRouters are worthwhile. Day one costs for a 6WIN Turbo IPsec perpetual license on a commercial off-the-shelf server saves customers over 50% versus hardware competitors. 6WIN Turbo IPsec's cost per gigabit per second of IPsec traffic is roughly $1,000, which is a very attractive price. When calculating the total cost of ownership over 5 years, we save our customers up to 80%. We welcome you to try this exercise for yourself. I will now turn it over to Jan for our VPN Concentrator vRouter demo.
Thank you, Kelly. This is our demo platform with the VPN Concentrator sitting at the edge of the enterprise headquarters. Remote workers and enterprise subsidiary sites open IPsec tunnels towards the VPN Concentrator for a secure connection to the enterprise resources. The VPN Concentrator is composed of 2 Turbo IPsec instances working in high availability mode, with VRP for redundancy and IKHA for seamless failover, thanks to the continuous synchronization of IPsec security policies and associations. The cluster is monitored using the Grafana visualization tool. We run each vRouter instance on 5 cores, 10 threads of a dual-socket platform equipped with Intel Xeon Platinum 8170 CPUs running at 2.10 GHz. Each instance is allocated 8 GB of RAM, and we use an Ixia XM2 traffic generator to inject traffic at high rate, and we emulate up to 10K remote IPsec connections thanks to StrongSwan's load tester tool running on a separate platform. Let's start by reviewing the VPN concentrator configuration using the CLI on the first VPN concentrator called VPN C1. Using the show config command, we start by reviewing system information. We see the host name, vpnc1.vpnc.6win.com, and the dimensioning of the vRouter's high-performance packet processing engine called the fastpath. We see that 2 NICs and 4 cores, 8 threads are assigned to the fastpath for this test. We can then dump the interfaces, showing a management interface, 1 interface to the LAN, and 1 interface to the WAN, 1 interface for HA synchronization, and the VRP interfaces used for redundancy. With this configuration, we will be able to demonstrate up to 10 gigabit per second of traffic in both directions, or in other words, 20 gigabit per second of IPsec processing. Now let's check the routing configuration. In this case, it is very simple, with static routes configured to send clear flows towards the Ixia. Next comes the IPsec configuration itself. We can see the general options tuning the capacity of the IPsec stack. We can see the VPN configured with security policies for the Ixia for throughput, and the load tester tool for tunnel establishment. We can see as well the pre-shared key used to authenticate IKE exchanges. And finally, the configuration of this VPN relies on templates that define the parameters of the IKE Phase 1 and Phase 2 negotiations, including Diffie-Hellman group, encryption and authentication algorithms, rekey time, replay window size, and more. In this test, we use AES GCM with a key size of 128 bits for the IPsec ESP encryption. We can check the equivalent configuration in XML format on the second VPN concentrator used for high availability. This is what a netconf client would send to the vRouter to configure it in a programmatic way. We see the same information, including routes, interfaces, IKE templates, VPN and security policies, etc. Back on VPN C1, let's check the status of the interfaces. We see that the IP addresses are correctly configured, and that includes the VRP interfaces, meaning that VPN C1 is the master for the high availability cluster. Let's now switch to the XR traffic generator. This is the IX network UI, where we can see the different flows. There are 8 flows configured in each direction using 2 10-gig ports. The throughput indicated by the XR gauges is for clear traffic. When encapsulated with IPsec, the packet size and therefore the throughput increase. With the algorithms used in this demo, 20 gigabit per second of IPsec traffic correspond to 18.9 gigabit per second of clear traffic throughput. Let's start the traffic, and we see that 18.906 gigabit per second of clear traffic can be processed without any packet loss, which means that we achieve 20 gigabit per second of IPsec processing. While the traffic is running, we can dump the packets on VPN C1 and verify that they are encrypted using ESP. Let's now have a look at the key performance indicators in the CLI. These key performance indicators include product information, such as license and version, system information, such as CPU or memory usage, networking statistics, and others. These are streamed from the vRouter to an InfluxDB time series database and displayed in the Grafana Analytics dashboard to better analyze the dynamics of the system. In the dashboard for VPN C1, we can see the status of the system, including CPU usage in Linux, CPU usage in the vRouter's fastpath. We see that we reach the link capacity for the one interface when IPsec packets flow, and a bit down the screen, we can see the IPsec ASA and SP graphs reflecting the 16 security policies and associations used to protect the XR traffic. Scrolling through the dashboard, we can also see process usage, user count, and disk usage. Let's now check the IPsec state in detail using the CLI. We can dump all IKE VPNs to review their status and the corresponding peer's IP address and fully qualified domain names. The total number of VPNs can also be displayed. And when needed, we can filter the output on a specific peer for debug purposes. The detailed output includes the state of the security associations, the local and remote endpoints, the lifetime of the security associations, statistics in bytes and packets, and more. Finally, the show log command allows to review the sequence of IKE events, and it can be filtered out for a specific peer. Let's now demonstrate tunnel establishment rate. Our screen is split between the CLI on VPN C1 on the top and the load tester command line on the bottom. Load tester is a tool from the StrongSwan open source project that can simulate the connections of IPsec clients at line rate. The VPN count on VPN C1 is 8 when we start the load tester tool. As connections start establishing, we can see the VPN count increase on VPN C1. In Grafana, the IPsec security associations and the IPsec security policy graphs show us the IPsec connections being established until 20K SAs and SPs are reached, which corresponds to our objective of 10K IPsec tunnels. We see on the graph that the Ixia traffic is still going through at wire speed. So we have just demonstrated that we can maximize the capacity of a full duplex 10 gigabit per second link with IPsec traffic while establishing up to 10K tunnels. Let's now check high availability. This is another Grafana dashboard where we see a high-level status of the redundant instances of the VPN concentrator. Both are active and in good shape. We can see from the FastPass CPU usage graph that VPN C1 is the active instance processing the IPsec traffic. FastPass CPUs are inactive on VPN C2, but we will see that the IKE sessions are synchronized and VPN C2 is ready to take over traffic in case VPN C1 fails. Here our screen is split between the CLI console on VPN C1 and VPN C2. The VRP configuration and state show that VPN C1 is the VRP master and that VPN C2 is the slave or backup. We can check that the VRP interfaces on VPN C1 bear the virtual IP address of the cluster, while there are no IP addresses on the VRP interfaces on VPN C2. This is for the link redundancy part. Now regarding IKE sessions, the high availability configuration shows the group, the synchronization interface, and the peers addresses that are used to continuously synchronize the IKE sessions between the active and inactive systems. We see the 10K plus 8 IKE VPNs configured on both sides. These have been synchronized on VPN C2 while they were established using the load tester on VPN C1. We will now trigger an activity SWACT by setting down the interface connected to the LAN interface on VPN C1. This will cause VRP to change states and VPN C2 to take over traffic. We can see from the CLI that VPN C1 is now backup, and VPN C2 has become master. The VIPs of the VRP cluster are now configured on VPN C2 for both LAN and WAN interfaces. Back to the Grafana overview dashboard, VPN C2's FastPass CPUs are now loaded, indicating that IPsec processing has been taken over. On the other hand, FastPass CPU usage on VPN C1 is 0. Now, looking at the detailed dashboard on VPN C1, it is clear that traffic is not being processed as the throughput on the interface is 0. On VPN C2, on the other hand, the throughput is 20 gigabit per second, meaning that traffic has properly been taken over thanks to the already established VPNs when the activity switch occurred. That concludes our demo. As you can see, we offer tremendous value in software for VPN concentrator solutions. To conclude, we have demonstrated how 6WIN's vRouter can be deployed on a standard off-the-shelf server as a VPN concentrator to terminate 10K IPsec tunnels, maximizing throughput on a 10 gigabit per second link, and providing redundancy and seamless failover, all these being monitored in a graphical environment. In our demo, we used 5 cores per VPN Concentrator instance and 8 GB of RAM, knowing that throughput scales with the number of cores and number of tunnels scales with memory. This is a testament to the power of our vRouter software. And now, I'll hand it back to Kelly.
Thank you, Jan. That was a very nice demo. And now we can see that there's some questions coming in. So let's open it up to Q&A. Remember to use the Q&A button at the bottom of your screen to submit your questions, and we'll continue to take them in the order that they're received. So here's the first question coming in. What's the performance of your VPN concentrator?
We have measured an IPsec performance of up to 18 gigabit per second per core. And remember, this scales with the number of cores. And we have measured 50K tunnels. This scales with the memory. And in this particular demo, we used an Intel Dual Xeon Platinum 8170. And we have shown 20 gigabit per second. And that was using 4 cores and 10K tunnels.
Okay, very good. Second question is, can you recommend a server platform?
Sure. So many of our customers use, for example, Dell PowerEdge R630 servers with Intel 10 gig NICs, and they are up and running immediately. It's instant. Other popular server includes the same kind of options from Advantech, HP, Lanner, and Supermicro, for example. For the VPN concentrator use case, we support servers with Intel Xeon processors and a choice of NICs from Intel, Mellanox, and Broadcom.
Okay. Next question. Which virtual machines do you support?
So you can run our vRouter on top of Linux KVM, VMware ESXi, and AWS today. We support Virtio, VMXNet3, SRIOV, and PCI pass-through, of course. And remember, with the same software, you can also run bare metal, and soon containers. We have container support in our roadmap.
All right, it looks like we have one more question, which is perfect timing because we're almost at the end of our webinar. So for the final question, what kind of redundancy do you support? What kind of redundancy do you provide?
So we provide both hot standby and warm standby modes, leveraging VRP for the link redundancy, as we saw in the demo, and the continuous synchronization of IKE sessions for seamless failover.
Okay, so these were great questions. Thank you all for your questions. This will include the Q&A portion of our webinar. And in fact, this will conclude our webinar. So if you have any additional questions regarding what you saw today, please don't hesitate to contact us. In fact, you can contact me directly, and I'm always happy to help. So we will say goodbye to you for now, and we look forward to speaking with you soon. Bye now.